So let's just look at a concrete example of a PCA analysis. This example is based on the NCI60 data, which is the data of gene expressions, in particular around 6,800 gene expression obtained for around 64 cancer cells. So it's a kind of nearly 7,000 by 64 dimensional data. This is obviously a very high dimensional data, and this is also something hard to look at. So one thing where principal component is analysis is useful for is, for example, to reduce the data to a two-dimensional projection, which is a good direction to look at the data. And we already saw from the example with the pen that it's much better to look at the pen from this direction than it is from this direction. Similarly, if I would like to have a kind of 2D projection onto the data, something which you can nicely plot, I better choose the directions of the first two principal components in which the data varies most. Potentially, if I look from a different direction, a kind of random direction, I couldn't really see any structure here. So this is exactly what you see here. Those are the first two principal components, and I can see how does the data look like in this space, or projected onto the space of the first two principal components, which is usually a very good space to look at such high dimensional data. Very good projection. If you want to plot it in 2D, such high dimensional data, takes the first two principal components and plot it. And below we also see this proportion of variance plot here. So again, this is proportion of variance, and we can see that some of the like first principal component, second principal components, they both explain around like 10% of the data, of the variability of the data, so quite a lot. And then it keeps on decreasing, I would say, kind of after around 10, as we said before, we only see a marginal benefit here. And you see it goes all the way down up to around 64, which is the total number of principal components here, which is equal to n, the size of the data here. So this is just some plot of where we see how principal component analysis is useful, just to be able to look at some of this high dimensional data, which is very difficult to look at otherwise. And you see the plane spanned by the first two principal component is such a nice projection of the data that we can actually see some structure emerging here. There seem to be some regions here which seem to be somehow separate to other regions here and other regions here. So we see some structure in the data, and this is actually something which brings us to our next topic, which is clustering, which exactly deals with that. Imagine I had some data and I have those structures. How could I potentially kind of cluster the data in kind of clouds of data points which are somehow similar by their proximity? And this is exactly what we will be doing in the following when we talk about clustering, which is another technique of unsupervised learning.